All right, geometry. Welcome back. Today we are going to talk about sector area. Sector area is a little way for us to be able to determine what is the area of different portions of our circle. So if we take like a pie slice, like a pizza slice of a circle, what is the area of that slice that we're taking compared to the area of the entire circle? So that's what we're going to look at today. You had a little bit of intro into this with Desmos earlier, where you did a little Desmos thing where you had to like change an angle to try to find a certain amount of area from a total. So we're going to talk about how we can actually calculate this. So starting off, we have to think back to 6th, 7th grade, and we're going to talk about what is the area of our circle. So our area formula of a circle, if I can get my pen up, area formula of a circle is the area is equal to pi times the radius squared. That's our area formula of a circle. That's what we should have remembered from our previous math classes. You should have used that plenty of times before. So area, once again, area is equal to pi times the radius squared. Now, all we need to know is the radius, because once again, pi is an irrational number. It shows up in all of our circles. Any sort of circular value we're solving for, pi will always show up. So all we need to know is the radius, and once you know your radius, then you have the area of your circle. So in this case, once again, the radius is from the center to the outside of a circle. If our radius is 5, our area would just be pi times 5 squared. Except I need to write the number 5. Pi times 5 squared. And then we can just plug this into the calculator, and we are done. So if we plug 5 times pi, or pi times 5 squared into our calculator, we get 78.54, and that is our area. Sometimes it might ask you to leave your answer in terms of pi, and what that means is just don't multiply by pi, just leave pi in at the end. So what we would do if we were to leave this in terms of pi, we would just do 5 squared is 25, so it would be 25 times pi would be the answer. And that would be leaving your answer in terms of pi, is where you just have pi, you don't multiply it in, you just leave it on the outside. But that's our area formula. That's pretty easy. So all we need to know in order to calculate the area is the radius. So that's our only key piece of information needed. So now let's talk about sector area. So I have this sector here. A sector is, once again, a pie slice, or like a portion of your circle. It's just that little slice, that blue shaded region. And I want to figure out what is the area of just that piece, just that sector. So we know because if we look at both these circles, the radius is the same, so the area is going to be the same. So we know that both these circles, the area of both of them is going to be that 78.54. So if I want to find just that slice, I just need to figure out how much of my circle do I want, and then I can take that out of my total area that I already know. So I know this whole thing is 78.54, and we got that from our formula over here. So I just need to figure out what is this portion. Well, I know this is 60 degrees. If I think, how much is my total circle? My total circle is 360. So I just want 60 degrees out of 360 degrees. Or I can create a fraction, essentially, to represent that. 60 degrees out of 360 degrees is really, if we were to simplify that, is just 1/6. So I just want 1/6 of my total area, which is 78.54. So if I multiply these together, that will give me my portion, however much I need, which would just be 13.09. So 13.09 is 1/6 of that 78.54, and that would be our area for this sector. So sector area is super simple. All we need to know is that angle amount of your portion of your pie slice, and use that to take out the total, or use that to find the value of the total area, and that multiply it by your angle slice or your proportion, and you are done. If to set up a more straightforward formula for this, what we can do is we know it's always going to be our angle of our pie slice divided by our total which is 360. This gives you your fraction. Angle divided by 360 is always going to be that fraction you have. We always know it's going to be 360 in the denominator because it's always out of the full circle, which is 360 degrees. And then this is always going to be multiplied by the area of the entire circle because we're just taking a portion of that entire circle. So that's the area of our entire circle is pi times radius squared. So this right here is our formula for calculating the area of a sector. Angle divided by 360 times pi times radius squared. That's all we need to know. And then really there's only two variables we have to fill in. Our angle and our radius. Pi is a number, 360 is a number, squared is a number. We're good. So let's look at some examples of these. 100 is my degrees. 8 is my radius. What's my area of my sector? So the area of my sector is going to be, once again, it's my angle divided by 360 times pi times radius squared. And all I need to do from here is just plug this into a calculator. Plug and chug. So we type that into the calculator, and we get... I wrote the wrong thing down, so I assume my number's wrong. So I'm gonna put this in my calculator really quick because I wrote the wrong number down. 100 divided by 360 times pi times 8 squared is 55.85, and that would be our answer. Sorry about that. I wrote the wrong thing down. All right, so that is our solution. So once again, it's super easy. All we have to do is fill in those two pieces, your angle and your radius, and you're done. Another example really easily. Once again, I have an angle of 140. I have a radius of 20. I just need to fill these two pieces in. So my angle, my area of my sector is going to equal 140 divided by 360 times pi times 20 squared, my radius squared. And if I plug that into my calculator, it gives me 488.69. And that is our answer. Super easy, super simple, nothing too complicated. It's really just a formula. You're plugging and chugging. You guys are good at this stuff. Ooh, here we go. All right. So the circumference of this circle is 100 units. What is the area of the shaded sector? So we know we just need two things to fill out our formula. We need the radius and the angle measure. Well, they gave us our angle measure of 45 degrees, but they did not give us the radius. Instead, they gave us this extra information. They told us the circumference equals 100 units. So they said our circumference equals 100 units. Well, what is the circumference again? Circumference is all the way around the circle. It's the length around your circle, the perimeter of the circle. So our perimeter of our circle, our circumference is 100 units. How can we use that to help us find our area? Well, if we think about our circumference formula that we've used in the past is 2 times pi times the radius. So 2 times pi times the radius is your circumference. So if we know the circumference is 100, we can easily solve this for the radius because we know what 2 is, we know what pi is. We can divide by those, and we can get our radius. So 100 equals 2 times pi times the radius. So if I divide by 2 pi, if I divide by this, those both cancel out, and I'm just left with my radius, which means I have to divide by 2 pi on my 100. So 100 divided by 2 pi is going to leave us with 15.91. Once again, these decimals would continue because pi is an irrational number, so I'm just rounding to 2 decimal places to make it easy. So my radius is 15.91, so I can put 15.91 here. And now I have my angle, I have my radius, and once again, this is super easy, plug and chug. So the area of our sector is going to be 45, our angle, divided by 360, the total circle, times my pi, times my radius, which I found was 15.91 squared. And this equals 99.40. And then they told us units, so we'll say units squared. Because we know it's an area, so it's always going to be whatever our units is squared. Because every area is going to have square units. Super simple, super easy. Once again, assuming you could remember to calculate how to calculate circumference, you could use that circumference to find your area. We have our radius, and we are good to go. One last question. All right. In the circle O, diameter AB, chord BC, and radius OC are drawn, and the measure of arc BC is 108 degrees. Some students wrote these formulas to find the area of the sector COB. Amy said 3 out of 10 times pi times BC squared. Beth said 108 out of 360 times pi times OC squared. Carl said 3 out of 10 times pi times 1/2 AB squared. And Dex said 108 divided by 360 times pi times 1/2 times AB squared. Which students wrote the correct formulas? So let's think. What are we asked to solve? So we are asked to find the area of the sector of COB. So we are looking for this portion here because this is COB. So we want that shaded region. Well, we know in order to find our shaded region, we have to know two things. We have to know what is our angle and what is our radius. Well, we do have our angle. We were told this sector or this arc length out here is 108. We know this angle is a central angle, which we've just learned about. Central angles are equal to their angle measure. And so that means this central angle is also 108. So we know 108 is our angle. So if we start up with our formula, our area is going to be equal to 108 out of 360. So we got the first portion. Well, now comes another part. We have to think, okay, what is the radius of our circle? Well, they didn't give us any values for the radius, but looking at our circle, we do have our center at O. So we should be able to identify some lines as a radius. OA is a radius. OB is a radius. OC is a radius. Because we know it's always from the center of your circle to the outside is a radius. So any of these values is the radius. So we would just need to multiply by pi and then times any of these radiuses squared. So I'm going to say OC squared. I just picked one of my radiuses squared. All right, so do we see this formula show up anywhere? We see actually Beth shares our formula. So we know Beth is correct. Beth is the only one that, let me plug that in really quick. I apologize. Beth is the only one who shares our formula with us. Where's that chord? Here we go. All right, got that. But we know at least two of our students are right because looking at our answers. So let's see. Does Amy have the right thing? So what is 3/10? Is that the same as 108 out of 360? Well, if we plug in 108 out of 360, plug this into the calculator to simplify it, this does actually equal 3/10. So those are equivalent fractions. So 3/10 times pi times BC squared. Well, what is BC? BC is this line right here. Is that a radius? No, that's not a radius. So we know Amy is not correct. We know Beth was correct because she wrote down the same thing that we did, so we know that's right. Is Carl correct? Well, let's see. What did Carl say? Carl said 3/10, which is fine because that's the same as 108, times pi times 1/2 AB squared. Well, AB, if we look, AB is our diameter. Half of AB would either be OA or OB, so that squared would be fine. So Carl is also correct. What about Dex? Well, Dex pretty much wrote the same thing as Carl. He had 108 out of 360, which we know is the same as 3/10, or 3 out of 10, times pi, times 1/2 times AB squared. Now, is this different than what Carl wrote? It is, because if that 1/2 is inside the parentheses, that means the 1/2 is being squared as well. This is saying you're squaring AB, which would be essentially you're taking the length of AB times the length of AB, and then cutting in half compared to squaring this portion. And we know squaring is not the same as multiplying by 2. It is you're multiplying it by itself. So this is a different length. So Dex, unfortunately, did not write it correctly. So Dex also is getting crossed out. So Beth and Carl is going to be our answer, which is number 2. And that's where we're going to end it for this time. You should have 2 little practices over this. One of this is a Desmos activity looking at this lava field. Another is just a normal typical practice with a little bit of spiraling on it as well. Let me know if you have any questions. I will gladly help you to the best of my ability. Other than that, have a great rest of your day. Oh, wrong button. There we go.